more minutes. But my guess is they asked me to do this because I have had the opportunity to work on some pretty unique and some might call challenging projects here on the east side, both in Oregon and Washington. And we work, our design teams are interdisciplinary. So true confession, I'm not an ecologist. I just play one sometimes. But I get to work with some really exceptional ecologists. And through that process, we've learned each other's language, hydrologists, geologists, engineers, to develop our designs. And here's the outline for my talk, or our talk, I should say. I'm gonna go over a little bit, umbrella style, the importance of assessment and design in this process, how what is now being coined geomorphic context plays a role in that, some of the analysis tools that we use, and then I am going to get into a little bit of nuts and bolts, talking about how some of those analyses are applied in the development of the revegetation, riparian planning components of designs. And then I'll hop into 3 examples. One will be starvation flats, which Shannon just gave you a whole bunch of background on. So I'll be kind of giving you a little bit more of the technical components of that and how we got to the decisions we got to install it. And then my 3rd example is going to be the Kittitas River, which was just installed this summer in the Upper Yakima. And then Mark Young from Kittitas Conservation Trust is actually going to come up and talk about the implementation process of that. And lucky you also have Wildlands here, because they did some of the, they did all of the installation up there, which you'll see had its own challenges. And so I think I'm gonna just kind of dive in. So assessment and design, to me, these 2 words go together, because designing without assessment really puts you at a lot of risk, and there's a lot of potential for things then to not work out or to fail. Not that we can't learn from failures, but if we have the opportunity to assess, let's do it. Assessment lets us put all these pieces together, including what the goals of the projects are, to help us identify and define what approach is appropriate for the site. And this is a way of kind of stepping into the design. I like nowadays that the common term for this is process-based restoration. It's really neat to have this kind of common vocabulary for it. And this is really important because every single site is different, right? Even a site that is just 500 yards downstream can be have very different needs than what you need at the site that you might be standing at. And you know, potentially as you do this assessment, you'll find out, well, what we need to do here is just identify the areas that are functioning and protect it. Maybe we need some strategic actions to reconnect the pieces that are functioning. Maybe we can actually restore back to historical conditions. Ooh, that's a pretty rare opportunity these days, right? Oftentimes what we end up needing to do is enhance or create new habitat inside the limitations of the anthropogenic influences, cultural permitting issues, whatever those things are. And you know, if you're at one site, maybe one of these approaches works, but oftentimes you're in a reach or in a project area that all of these or some of these all play a role. So doing the assessment process helps you identify what your approach is going to be. And again, assessment and design all work together. As I said before, there's all these steps to the assessment process before you can even get to figuring out what you want to do on the ground and then designing it so that it's appropriate for that site. And for me, and for the work that we do, all of us here in the room, when I step on a site, vegetation is one of the key components that we really think about inside the geomorphic context of what is influencing that project area. And geomorphic context, this is the channel, its floodplain, and all the subsurface interactions that are happening through there. And these are really the controls that are influencing that river. So even though you're standing on a particular point in the river or a wetland or even a hill slope, there are things that are happening upstream, there are things that have happened in history. What's the geology of it? How did the landscape evolve to get to where you're at? What's the climate here? How is the climate different in the headwaters of that watershed compared to halfway down, all the way down at the confluence with the Columbia? How are those things different? Past and current anthropogenic alterations. Is there a levee on it? Are there bridges? In the past, was there fire management? Was there cultivation of plants there by humans in the past? You know, sometimes good alterations, sometimes maybe so good. But all of these things, they mix together to make a fabric of a place. So that we like to call that geomorphic context. And I was really stoked to see Ellen Wall et al. Just this last year publish it and use that term, geomorphic context and process-based river restoration. So that's a reference I suggest everyone checks out. Anyway, basically plants are part of this whole equation at all times, right? And the role that they play, just like the role of geology or the role of sediment influx or the role of large wood, is different from site to site. And I like this graph. This is Castro and Thorne 2019. It's an evolved version of a diagram you saw earlier today. And I like how this lays out how channel form, it's a pretty interesting example, or I should say depiction, of three primary controls that take into consideration the geomorphic context of a site. So these are three primary controls that can really influence channel form and function. And I'm just going to kind of give you an example. So if you're, pardon me, I forgot I was going to highlight that little comment box there. I should have brought my notes up here. You get me winging it. Biology, even if biology is playing less of a role, it still plays some role. So for example, let's say you're down here in this part of the triangle. You're in a confined section, it's bedrock controlled, there's high discharge stream power, pushing sediment through here, but there's still biotic interaction, right? Perhaps that vegetation it's not controlling the channel form, but it's still producing nutrients. It's still going to produce some shade to potentially a little refugia area behind a boulder for trout or salmon to tuck into. And sometimes it's also going to produce large wood that falls in. And maybe that large wood is only temporary in this particular reach, but it'll float downstream and then influence the next reach downstream. So let's go to the other side of this triangle. This is a wide alluvial valley, really low gradient valley, really low gradient channel, high sinuosity, multi-threaded. And in this scenario, the vegetation is actually is a huge controlling force on the channel itself. And then of course, we can hop to the other side of the triangle. Here we've got enough stream power to be moving active bars, gravel, boulders, moving down this system every year. It's not confined, so the geology hasn't confined it, but the geology upstream is producing enough sediment to give it this kind of sediment load to move it. But vegetation potentially can establish on those bars. If vegetation is able, if there's some sediment flux variations, if there are some hydrologic variations, let's say a glacier has receded, discharge regime has dropped, vegetation can encroach, some of those bars get established, and potentially the influence of the stream power might vary. So you might go from a braided system up into a more meandering system with vegetated bars. So these can even flux and change as the channel evolves over time, or even in response to human interaction. So this is the kind of assessment you're going into to kind of go, what's going on here? What's at play? Which of these threads are strongest in the fabric of the geomorphic context of my site? And this all plays, you've also seen this diagram before. I brought this up as an example. So you can, oh, whoops. Oh, that was supposed to pop in later. I was going to ask you guys a trick question, but now you've got the answers with the lines there. Oh, well. So you might look at this, this photo over here. You've got this historical floodplain up here, massive incision. This is 10 to 12 feet. So you might think, oh, this is just a channelized system, but the vegetation is telling us something. The vegetation is telling us that there was a little bit of an inset floodplain here. There was some riparian vegetation, but these trees, they're about 15 years old. So in the last 15 years, incision has continued. And even that inset floodplain is starting to become abandoned, right? So whatever has influenced this channel to a state of degradation is still there. It's still incising, it's still going down. So this is more arrested degradation or maybe stage 3 process of degradation. So here's another example. This is what we would call a quasi-equilibrium. It's disconnected from its historical floodplain, but its stream load, or pardon me, its stream power and its sediment load has developed a nice meandering system, and there's an inset floodplain, and there's a really nice set of established riparian vegetation. It's quite narrow compared to probably what it was historically. So when we assess and look at all these variables as they contribute to each other, to the channel that we're stepping into, or the wetland we're stepping into, or the meadow we're stepping into, this helps us understand where the channel's at in its evolutionary process. What is it responding to? How is it responding? And that helps us understand if we apply certain things to this channel, it gives us some information about, there we go. It gives us some information. Did I do that? It's good now, but it went black. Okay, all good. It gives us information about how to predict how the channel will respond if we apply restoration actions to it. So it helps us, it gives us that kind of information. Some of the field assessments that we do specific to revegetation that we recommend, there is all kinds of digital desktop analysis you can do, field mapping you can do, things like that. But identifying what is growing where, especially if it's something that you want. If you've got a nice established riparian corridor, if you can map that and figure out its relationship to the groundwater and the surface water, how frequently is it inundated, what's the soil type there. You want to then come over here and do restoration, say in this area where the channel's incised and disconnected. You can then use those conditions to help you figure out what you're wanting to restore to in that general area. If your system, if the systems are connected like this. Another thing we do are these test pits, looking at inside the floodplain or the riparian area, doing a test pit. It can show us where the groundwater is at the time of the test pit, but it can also show us what the floodplain is composed of. Does it have a really thick organic surface? Was it a floodplain? Was it developed with fines? Is it gravels and sands? What are we dealing with here? When we do these kinds of test pits, it also gives you the opportunity to install a piezometer tube to do groundwater monitoring, so you can gather some of that information over time. And this helps us here. This is our median. This is the median we're going to be putting plants in. What would be appropriate there? If the groundwater is 6 feet down, is it material that can wick that moisture up and support that plant or not? And Michelle's going to go into more of that later. But there's all these different tools in our toolbox. Don't really have the time to go into all of them right now, but I'm going to move on. One of the ones I do really want to talk about, though, is hydraulic modeling. This 2D hydraulic modeling has become a really valuable tool that we utilize when we are designing not just the structural components of our design projects, but also the revegetation components. Because this allows us to identify, these are under proposed conditions. So if we apply these restoration tactics here that we think are going to work to help reconnect these side channels, provide fish passage through a bridge, reestablish connectivity through side channels that have been disconnected for decades along a larger stream across the floodplain. If we do that, how often is this inundated? What is the frequency of that inundation? Can we get it to be inundated all year long? Can we get it, do we want that? Do we want it to be a wetland area? Do we want it to be seasonally wetted? What are we going for here? What are the flow depths? What are the flow velocities? And this gives us really critical information about where to plant, what to plant, and what kind of techniques to use when we go to plant those plants. Next part of this is once we have found that magic place where we think we're maximizing the potential that the restoration can provide to the function, the geomorphic function, and the ecologic function. And we've modeled where these things are going to go, and we've tried to identify what to plant where. Mint. is what are we going to plant? What are we going to plant at this site? What is appropriate for this site? And some of the things we really think about are native species, of course. Everyone in here can agree to that. But as we move towards thinking about climate resiliency, we're really trying to have these conversations to not just go, okay, well, there's native coyote willow here, so we're just going to plant native coyote willow. Well, what if what about climate change? What if it gets warmer? What if are there other species of willow that are native that would be appropriate here that could build resiliency into the vegetation community? And maybe not just willow. Let's diversify, not just within the species itself, but other kinds of species. So doing that, one of the most valuable tools we've found is traditional knowledge about what used to grow there in the past prior to degradation. And once we know that, we can even design for those conditions to support those kinds of plants. And that's an incredible tool if you ever have the opportunity to have that information. And then, of course, once you know what those plants are, what kind of hydrology do they need? What kind of soil and climate requirements? And then the whole idea is to design these restoration projects, so not just the structures that you put on the plant or install on the landscape persist and evolve and maintain themselves, but so does the riparian vegetation, depending on what their role is and the geomorphic context that the plants play in the system. So, talking a little bit about site-appropriate installation techniques, again, I'm going to kind of pare it down to a couple examples here. The one on the left, this is actually up at Starvation Flats. This is a laid-back bank. It was an incised bank. It was incised about 7 feet down. And we cut that bank back, took the materials on the side of the bank, raised the bed, and the water in here it's going to back up into that area, but the soil here is so incredibly erosive. It's a volcanic ash, and they had collected some native seeds. We put locally collected native seed underneath the coir, and then take the coir, and these will all get staked. And we don't do these on banks where there's going to be high velocity, right? Just low velocity flow regimes this can handle. And this is really going to have a back watering that's going to happen. We're raising the groundwater table here. But if we just laid seed on these banks without that protection, it was just going to, float down and puddle into one area, and leaving these highly erodible banks open for more erosion and also open for weed establishment. So this was a technique that we did at Starvation Flats. There's all different kinds of fun techniques for installing plants, and willow's one that we've found in these higher energy places. So you can see the line of willow, and this is actually willow and dogwood getting installed. This is the line that's been modeled to be the ordinary high water. So we wanted to put them in, and they're being installed at base flow. This is in a new, it's actually an area that had been leveed. We took the levee away and re-meandered the channel back into its historical form. And so this is a new bank cut. So no coir fabric here, right? Too high stream power. But how do you get these willows down into this median without damaging your willow stakes, making sure that it's nice and wet down there for their toes to land in. So we had a bucket came in and pulled back the banks because we had access there, right? We were in construction. And a technique that we found that's really helpful in installing willows in these more higher stream powers areas is to install them in clumps. Instead of just a single line where they're all 1 foot apart, installing them in tighter clumps. They kind of support each other, and we've had really high success rate, including here. So just one little bucket, it pulls it up, set them in, drop it back, and it falls back down. And then this kind of technique gives it that kind of clump resistance to the hydrology. And once you do your analysis and you know what your depths are and what you're working with, you can then decide, do I need a 2 foot long live stake, or do I need a 4 foot long live stake? Similarly to your vegetation, and how deep do they need to get buried to get to your water sources. So now I'm going to jump in. How am I doing on time? Perfect. Now I'm going to jump into these 3 examples. This is called Middle Fork John Day. This is actually in Oregon, but it is east side. And it proposed so many interesting, I was supposed to talk about challenging design projects and revegetation conundrums that I wanted to share this particular one. So this is the Middle Fork John Day River, and you might not be able to see it. It might just kind of look like a track, but right there, you kind of see it as I click it back off and on. That's an old railroad prism. So that's a big levee running right down the middle of what was historically this entire valley used to be wetted. We'd seen photographs. You can see the old scarring. We took soil plugs out there. It was definitely a wet floodplain soil. But now the channel's basically straight, totally in size. There's hard points along the road, riprap and things like that that keep it sucked down and low. So our conundrum here wasn't, should we reactivate this whole meadow? We already knew that. So we wanted, how are we going to do that? What's good for fish? How do we reactivate it? Super low gradient system. So this is going to be a vegetation channel form controlled system. So if we do that and we put the channel back out here, we don't really have any vegetation over here. It's so dry and hammered by agriculture. So how do we do that? Well, luckily we were able to do this in 2 phases. So we were able to construct phase 1 in the first year, which meant we got to recreate channels out through here. We closed off this ditch so that the tributary water that was coming in off the sides that captured went into that, and it started to establish it. And then the following year, we did phase 2. So right here's there's the levee, or railroad prism that was acting like a levee. And you can see that what was constructed in 2021, we did very, very minimal vegetation disturbance in anything that we cut up. Here's our little deep, narrow, undersized channels. There's a couple of them rolling through here. Anything we dug up, we used those sedge mats to recover any kind of impact we had. And then in 2022, this was a bigger construction project, right? We actually had to take a railroad prism out. We had to infill with that material, the levee material. We infilled the old straight channel, recreated sinuosity through here and multi-threading. And so in here, well, I'll get to this a little bit later, but in here we had to do a little bit more revegetation and planting. But, and that got finished, phase 2 got finished summer of 2022. So its very first spring freshet was last spring, April 2023. Full success, full valley-wide activation, super exciting. And this was last August 2023. Super thrilling, right? I'm just so stoked about it. One of the techniques we used here in this area that was a little bit more exposed, right? It didn't have as much vegetation. And this vegetation, it's converting from those dry grasses, and more of the seed bank that was in those soils is now starting to come out, which is super exciting. But to help us over here, we did these things. I don't know if you can see, the picture's kind of small, but we call these willow trenching. So we actually have a machine come in and dig a big trench, and it hits groundwater, and then you place these like 6-foot-long willow stalks in there, rebury it. And so these run across the floodplain, and these provide roughness in areas where vegetation has been disturbed. And it might be a little hard to see, but right down here is where the road prism was, and you can see those willow clumps really successfully running all through there, and then we had some more in here. So that's a really fun technique in places where you can do that. And we raised the water table here about 3.5–4 feet. And I know it's super exciting. In August, this is August, and it varies throughout here. We wanted to have a lot of complexity and variability, and we want the system to move around and shift and change, right? But even in August, you can see down here in the section that hasn't been restored, it's dry, but here it's nice and green, and the water's about 6 inches below, 6 inches to maybe 10 inches in the deeper areas from the surface of the floodplain. So that's really exciting. Next place I want to touch on, Starvation Flats, and Shannon gave you a lot of background on it, so I'm just going to kind of hop into the things that we considered. Again, these is highly erodible ash soils, so that was of concern. We also, we also had to really think about the cultural impacts here, and how to apply something where you wouldn't have to come in and out. Like we needed a one and done here. This was a pilot project. It was really sensitive. area. As you know, I think Shannon really reiterated, this is an important spot for a lot of the people that still come up there and utilize it. So it was a high profile kind of situation as well. And what we ended up being able to do is we selected the pond and plug treatment in this area. There's lots of ditches. There's some ditches to fill in the phase 2 section, head cut revetments that we did. And the considerations that we did was this traditional knowledge about what the historical conditions were. So when we heard from the elders what they used to collect up here, we were like, wow, this meadow is wet for a good part of the spring and summer. It might dry out by like fall time, but you know, to support those kinds of plants, including camas and yarrow, it needed to be wetted. So we had a low gradient valley, which allowed us to work with these erosive clays in a way that we couldn't if we had a higher kind of stream energy that we were going to be dealing with, but we didn't have that. So it gave us these opportunities. We also thought we're gonna, because of the concerns from the Yakama Nation, we're gonna depend on the seed bank, which we found in some soil plugs, and then as time went on, also rely on the cultural or cultivation techniques of the tribes, where you can pull and plug or pull up the bulbs and replant them around where you want them. So this is this is a hydrologic flow model of the phase 2 area, and these were the plugs that were designed, and so this was what the model showed us, and so we knew, you know, where we would be able to expect some things to happen. So this is pre-project. This is just 1 year post-project in the phase 1 area. Now there's 4-foot tall willow growing through here, which is super exciting. This is the downstream plug. It might look a little big, but at the upstream end, it was only 2.5 feet high. So not a big, tall plug. We didn't need a lot down there, but we needed a geologic control imposed. And just 3 years later, even though we didn't seed this, we knew that the water would be moving through these rocks, and it now looks like that, which is very exciting. So this was just taken summer of 2023. It was, sorry, that's wrong. It was installed in 2017. So this is what that pilot project now looks like. This is a photograph that one of the Yakama staff took for me this last summer. So yay, super cool. And this is phase 2, which was just installed fall of 2022. So this is July 2023 after its first wetting, and much wetter in the areas as we expected, which is super exciting. These are not rock plugs. Up here, it's lower gradient. This was able to just be soils, which was really, really cool. And they've already said that there's coir fabric on top of these just for erosion control, but that there's already vegetation starting to pop up through there, which is super exciting. And I was told a sandhill crane was spotted in this pond. So that's exciting. Last example is Kittitas River. And this was installed, we're on the other end of the spectrum here. We are no longer in the low gradient, low stream power. This is a really flashy system. It's so flashy that it moves gravel and sediment gravel and cobble just about every single year. And then at the end of its hydrograph in the summer, it gets low enough that it actually subs out. And Mark's going to tell you some about that. So that was an interesting thing to contend with. Let's see, design considerations of greatest importance: hydrology, hydraulics, climate change resilience in this scenario, species diversity, and riparian planting zones. We didn't want to put plants where they were just going to get blown out every single year from these high stream energy situations. So here's a little snippet of some of the hydraulic modeling we were doing. So the yellow spots are the high energy. This is your 2-year flow event. But this also allowed us to see where we could plant and how close to the edges we could plant. And here's a little kind of planting plan diagram over here. Mark will go into that a little bit further, but just wanted to give you a shot at that. So pre-construction, this is that same photo you saw earlier. This is the same spot. Our technique here, because this system used to be much narrower, they came in and logged it. They came and clear cut it. Huge, massive cedars and fir trees were removed off this beautiful, wide glacial outwash alluvial valley. And they did that, and all of a sudden, the hydrology became the controlling factor in this channel form. And it just spread out and blew out. And as trees and vegetation tried to grow in on that floodplain, it would just blow it out. So that it's almost 4 times wider than it used to be before they clear cut it. So when you take a system that's really flashy like that, it's hard for the vegetation to come in and establish. So this is all second growth, trying to come in. So the wood is contributing to it, right? The channel's coming over and grabbing it, but it's just so small, it doesn't actually influence channel form, and it's just washed down or only temporarily plays a role. And the only place we found any kind of scour or channel form control or any kind of floodplain development was where, down at the bottom, where an old growth tree that was still, there's a little section of old growth that still touched the channel, and it would fall in. So there's like 3 or 4 scour holes that were functional in here. And it needed to be a big tree. So our log jams had to mimic 2 big, giant old growth trees. And then in the lee of that, hydraulic control, which is designed to produce and maintain scour here, so that when the water subs out, we have these sequences of big, deep pools that are still watered by groundwater. And so there's refuge for the fish to go into. But in the lee of this hydraulic is a place to develop floodplain. And the hydraulics here are so rowdy sometimes that we actually put all these vertical piles in to act as like a standing forest, and then dressed that with a lot more roughness, and inside of that we planted. So yeah, how are you gonna do that? Let's plant something inside of this big mess, inside gravel and cobble. You get to learn about that next. And make it successful. We also reattached a side channel in the logging processes. They graded this whole floodplain, took all the wood out of the channel, logged it right up to the edge of the channel, and actually disconnected tributaries. If the confluence happened to be where they wanted to log or drive something, they just disconnected it. So we were able to recreate a side channel through here to reconnect Watermelon Creek annually to the main stem channel. And in doing that, we were able to model out, figure out the elevation for a little inset floodplain, which will be a riparian, that's planted as riparian corridor, and then the banks will be more forest corridor. And we tried to make this footprint as small as we could, so it does have slightly steep banks, but this is just a high flow side channel for high flow refugia for fish. Okay, so the whole point here is preserve, restore, and create over time. And this is a photo that Mark gave me. I just love this picture. This is looking upstream. You can see here these big floodplain bars that we created. It's kind of like a messy forest, doing our best to mimic what was maybe out there on the landscape. Some split flow, really confining the flow so that as the water goes down, there's more of it in the channel over time and more for fish, and scour. So I think I'm going to leave it with that, so that Mark, you can hop into the specifics of how the heck the vegetation was installed in here and all the other details about the Kittitas. Yeah.
Got it. All right. All right, well, thank you. So I'm going to talk a little bit about the implementation of this project. And this is a different way that I normally talk about it, because I normally get to focus really on the large wood structures and the fish. But this time, we're going to try to focus on the plants. But we have to talk a little bit about the fish still, because this was a bull trout project. So the bull trout were listed as threatened by the ESA in 1998, and the Kittitas bull trout population in particular is facing a lot of challenges. They've been cut off due to the dam from other populations of bull trout. so they're genetically distinct. Their habitat in the Kittitas River, where they return to spawn, is increasingly fragmented due to dewatering as a result of basically poor logging practices. And then, natural resource extraction, so the logging and the mining over the years. And with climate change, it's just gonna get worse. So here we can just look real fast at some of the advancement of the clear-cut logging. So basically no logging happening in the 40s. And then the 60s and 70s, they clear cut on the eastern and western side of the channel. In the 80s and 90s, they just took huge parts of the watershed adjacent to the channel. And so what we're left with is this over-widened, simplified channel that is really lacking in the kind of habitat that bull trout need to survive. And so, so here's an example of that channel simplification. This is, you can just barely see the lake at the high water out there, and it's like, it's over widened and just simplified. And so the removal of wood and the clear cut logging practices have just done a lot of damage. And so this prevents bull trout migration upstream for spawning and just diminishes the quantity and quality of their habitat. So KCT's mission is to protect and enhance critical wildlife in the upper Yakima River Basin. And so through that mission, we do a lot of bull trout work. And so the overall goals of this project were, how can we improve the quality of habitat for migrating and spawning and rearing bull trout? And because the conditions for the bull trout were worsened so dramatically by the effect of human activities on the riparian forest, the key to fixing that problem is to helping the system recover its riparian forest. So we know that old growth trees and mature riparian forests have been shown to impact channel morphology, including the formation and maintenance of bull trout habitat through the scour holes from the root wads. And they also affect sediment transport and deposition, which has pretty big impacts on spawning habitat. And the lateral and vertical stability of a channel. So therefore, riparian growth and recovery is an essential component of bull trout recovery. So here's an example of like the kind of feature that Polyanna was talking about that we're trying to recreate with the large log structures. And so a tree has fallen across the channel, and then its root wad, through interactions between the root wad and the hydraulics of the stream, it creates the scour hole. This is an extremely important pool because it's the furthest downstream pool that stays wet all summer. And so this is like the last stop for fish that are trying to survive this really, really tough summer on the Kittitas. And so we didn't modify this structure. This was one of the ones that was actually functioning properly, and the plans were designed around it. But we did add some wood, so we just added a bunch more large wood to it to hopefully help it persist and continue to function. And so that kind of gets us into the revegetation aspects of this project. And so we had riparian planting, we had those bar roughness structures that Polyanna mentioned, and then upland planting. And it was always a huge priority of this project to protect existing vegetation. So it doesn't make sense to come down and bulldoze the river channel like the loggers did and then try to replant it. So there was a lot of challenges to navigating the system with preserving what was still there while also trying to improve it. And so this is a look at the revegetation plans, plan sheets. And so you can see it's like these purple areas are the bar roughness structures that are associated with those large wood jams. And then up here is the side channel that Polyanna was showing us. And so it's just, I just wanted to highlight how specific and like thought out these planting plans were developed. And so in the side channel, we have these floodplain benches planted in close conjunction with this upland planting, which is a kind of more yellow. And I think there's some pictures. And so here's a picture looking down the newly constructed side channel that's designed to activate in the spring high flow events and give young of the year and juvenile bull trout and other salmonids and fish refuge from those high flows, so they don't just get washed downstream to pools that eventually dry up or even all the way out to the lake where they just are easy prey. And so you can see there's little plants that were installed on these floodplain benches, and as the thallweg kind of is sinuous down there, on each side of it, there's these floodplain benches, and then the upland planting you can see because it has these mulch rings. And so here's an aerial view of the inlet to the side channel. So this is the big log structure to give stability for this inlet for the high flow side channel, and then you can see there's these floodplain benches intermixed with the upland riparian planting to hopefully give that new side channel some structure as it establishes. And then again, these are the bar roughness areas. So let's see, I had something to say about these. Yeah, so the planting was modeled after existing vegetation and in close collaboration with the U.S. Forest Service to pick appropriate species, try to get like genetic stock that's going to give the plants the best chance at survivability. And let's see. So the bar roughness structures and the vegetation on them are essential to improving the channel dynamics and the hydraulic functions of the system by promoting sediment deposition and active channel narrowing. The riparian plantings outside of the channel serve to stabilize the banks and the newly constructed features and give stability to graded areas, suppress weeds, and promote the recruitment of resident vegetation. So in these kind of difficult environment to plant plants, it really helps if you start with high quality material. And so the water table's low, conditions are less than favorable. We need these like really healthy, happy, rooted plant stock to install and give them the best chance. And so I'll say too that all the mulch for this project was generated on site. All the trees were harvested for this project on site with the goal of forest health management in mind, but also to just keep everything local and not have to import anything. And so that was a really nice thing. We did have to use some weed-free straw to lay down over some of the seeded areas, but with that exception and a few trees, everything was gathered on site. And so here's an example of like a riparian planting area that hasn't been seeded yet, but you can see like this isn't really like super friendly looking substrate to plant plants in. Even with the mulch rings around it to help retain moisture, it's just really important to have good plants to start with. They were able to stage these plants right next to the stream, and so they could give them a good watering right before they were installed. I won't spend too much time on this because you'll get a good dose of that in just a minute, and I'm going to keep it moving for the sake of time. But this is the expandable stinger that Wildlands uses to put these plants in the ground, and it's pretty awesome. And they were able to plant or install just under 14,000 plants in about 3 to 4 weeks, which is pretty amazing. So a big challenge of this was the sequencing for the planting and the construction. So the planting all comes at the end of the project, but the planting is like arguably one of the most important aspects of this project for its success. And so it was really critical to kind of figure out how to get these plants in and give them the best chance at survival. And so the groundwater is really low. There's not really any surface water. We had the in-water work window to contend with. And so if we get channel reactivation like here, and this is actually the photo that one of the last photos that Polyanna had, but from a different angle. So this is the old logging road access after it's been decommissioned. But if this was our main access point to most of the downstream structures, and so this was the reactivation of that channel just after construction ended, and it's like we would have been totally cut off. So it's kind of this like crapshoot of timing it. We want to wait as long as possible to get the plants in the ground so that they're as close to a precipitation event, and also it's going to put conditions that are going to put them into dormancy. But at the same time, like we don't want to get cut off, and we want to make sure we can get everything in. So in this case, it worked out perfectly, and we were able to get all the plants in and close the whole thing out. And then it started raining, and the channel reactivated, and it was pretty awesome. And when I went back in early November, all the plants were looking really happy, and so that was encouraging. So hopefully we'll be able to come back in a couple of years and show pictures of how happy they all are. And so in terms of sequencing for these bar roughness structures, it had to be highly coordinated between Wildlands, which is the planting contractor, and then our general construction contractor, BCI. So these vertical pile were installed, and then everything was kind of staged on the sides until Wildlands could come in and use their stinger, which is conveniently mounted on the end of a excavator arm, so that they can work from the outside in and install all these plants. And then as soon as they were done, then BCI would come back and interlace all of this racking and material to finish out the structure. So it was like kind of this like hopscotch of coordination backwards from downstream up. And it all worked out really well, but it was like everything just had to be, you know, really well coordinated. And so communication was essential to the success of this phase of the project. And so you can see the little plants interspersed throughout, and then the operator that was for BCI would come back through and very carefully and skillfully intertwine these logs perpendicular to the vertical pile without smashing the plants, and then spread the slash to hopefully give everything its best chance. And so here's another example of the coordination that was required. This is the old logging road that was put in probably in the 60s, and so it's been, you know, decades of compaction. Was still a listed Forest Service road. So what would happen is the BCI would come through and decompact a section of that road, and then Wildlands would come back and plant it, and then BCI then would go back and somehow spread those logs back out to finish the decommissioning of that road, which you end up with something like this. So you have like the straw is over the seeded areas, and then all of this material to hopefully make it as unroad-like and unfriendly for would-be recreators to kind of enjoy it. But it also makes it really hard for our monitoring crews doing fish surveys to to make it around down there. But yeah, so you can see the little happy plants, and yep, and I think, yeah, so that's what I have, is a lot of partners that came together to make this project happen. Many of them are here, and we owe great thanks to all of them. And yeah, that's what I got.
So we have 5 to 7 minutes available for questions. Y'all are used to yelling now.
About the middle part, John, with your project
Yeah, so they're actually monitoring that middle part. And we only have 1 year of data so far, and right now it's all looking very positive that it's a low temperature reach, or not low temperature, but temperature compared to historically, because it was in the prior to construction, it was in that one single channel, and then further anyway along it, and now it's in these undersized channels, but the channels are narrow but very deep for fish passage, and the vegetation is controlling the edges, so they're developing these nice undercut little spaces for them to hide in, and yeah, the temperature in there. They say right now it's very good.
Yeah, so it was, yeah. Oh, yeah. Well, yeah, and Polyanna can speak to this too, because she was highly involved in all the sequencing. But yeah, I think it was just being able to get in, because the large wood that was kind of perpendicular to the vertical piles would actually extended beyond the footprint of where just those piles were. And so in order to be able to get the plants into the center, are you talking about the large wood of the structure, or you mean just like the whole, like the big engineered log jams? Uh-huh. Oh yeah, sure. They could have done that by hand, but we had so many plants. It was like 14,000 plants that you know. So I think, and they did go back and do some hand planting, but it was mostly just because we had such a limited window, and the ability to utilize the machinery was really key to being able to get it completed in the window that we had.
The seeding and the mulch was all laid down by hand afterwards. And side channel that you saw, they were unable to get the stinger into that because we didn't have such a small little access road, so that was all done by hand. We do a variety of different models. Sometimes if it's a wetland, we'll do some groundwater modeling, especially if we have actual data to verify groundwater elevation. What you saw here was Tetra Tech 2D. That is extremely useful. It does require that you have a nice continuous digital elevation model of the surface to allow for that. We find it probably our most valuable tool when it comes to it. It has limitations when you start looking at the groundwater component. That might be, I'll talk to you later. I'm getting the signal. I'll talk about the modeling that went into it. When we model that proposed out on the coastline, so we are definitely gets this wash down, so we don't think it's going to solve. Our other focus was to create but Mark can talk to you about how they're going to be monitoring that.
Yeah, so we did. So we haven't been able to get back up there. This project wrapped up at the end of last summer. So, and then the snows came, and we're kind of not able to get up there easily. So right now it's probably raging, or soon will be, and we just don't know. But we do have cameras set up, and then we also installed a bunch of ground and surface water monitoring stations throughout the project site, both on the floodplain and in the channel associated with some of the structures. So we'll be able to get an idea of like what some of the like changes are and how all that behaves and interacts with these new structures. So yeah, and this was like the abridged Kittitas project. There was a lot of things that went into it in terms of reconnecting floodplain and working towards, you know, hopefully recharging the aquifer and things like that. So.
Thanks. Thank you.